The directions say to find the equation of a plane. In example 1, we want the equation of a plane through the point 5, 3, 5 with normal vector 2, 1, negative 1. And remember, to find the equation of a plane, we need a point on the plane, and we need a vector that's perpendicular to the plane. So if we recall, the general equation of a plane is a times x minus x naught plus b times y minus y naught plus c times z minus z naught is equal to 0. And in general, the normal vector to the plane is ABC, and the point on the plane in general is x naught, y naught, z naught. So for this specific example, my A is 2, B is 1, and C is negative 1. X naught is 5, Y naught is 3, and Z naught is 5. If we plug that into the formula, we get the following. We get 2 times x minus 5 plus 1 times y minus 3 minus 1 times z minus 5 is equal to 0. Now we need to simplify. So if I distribute the 2 to each term within the parentheses, we get 2x minus 10 plus y minus 3, and then distributing the negative 1 to each term within the parentheses, I get minus z plus 5 equals 0. And so simplifying further, we get 2x plus y minus z, and then negative 10 minus 3 is negative 13. Negative 13 plus 5 is minus 8, and then this is set to 0. And that's how we do example 1. Let's take a look at example 2. Suppose we want the equation of a plane through the point 2, 0, 1 and perpendicular to the line x equals 3t, y equals 2 minus t, and then z equals 3 plus 4t. Now, one thing I want you to note, v, which is equal to the vector 3, negative 1, 4, runs parallel to the line x equals 3t, y equals 2 minus t, and z equals 3 plus 4t. Okay, now I want to draw a picture for you for a second here. So we have the equation of a plane right here. And if you don't mind, I'm going to call this point P. So 2, 0, 1 is point P. So point P is on the plane. Okay? And by design, this line is perpendicular to this plane. So we have a line perpendicular to the plane right here. And V is a vector that runs parallel to the line. So V is a vector that runs parallel to the line. And if it runs parallel to the line, it's perpendicular to the plane, if that makes sense. So in other words, by design, my A is 3, B is negative 1, and C is 4. And X naught is 2, Y naught is 0, and Z naught is 1. And so 3 times x minus 2, right? A is 3, minus 1 times y minus 0, plus 4, that's c, times z minus 1 is equal to 0. So 3x minus 6 minus y, and then distributing the 4 inside, plus 4z minus 4 equals 0. So 3x minus y plus 4z minus 10 must equal 0. And that's how we do example 2. So again, notice how I read off the coefficients of t to get my vector that's parallel to the line. So notice how the first component was 3. That's the coefficient of t in the first equation. -1 is the coefficient of t in the second equation, and that just so happens to be the second component. And then the coefficient of t in the third equation is 4, and that happens to be the third component. And that vector that we formed is a vector that runs parallel to the line, and if it's parallel to the line, it's perpendicular to the plane. And that's how that works in a nutshell. And with that, let's take a look at example 3. We want the equation of a plane through the point 3, -2, 8, and parallel to the plane z equals x plus y. Now, if z equals x plus y, then x plus y minus z equals 0. Now, n, we'll call it n, which is equal to the vector 1, 1, -1, is perpendicular to x plus y minus z equals 0. So if this vector is perpendicular to x plus y minus z equals 0, and we want a plane that runs parallel, see, notice if we draw a picture, pretend like I'm drawing a plane, and then here's a second plane, right? And n is a vector that's perpendicular to the known plane, right? Which means it has to be perpendicular to the plane that I want. And that's exactly what I'm going to say. So n, which is equal to 1, 1, -1, is perpendicular to the plane I want. Now remember, n equals 1, 1, -1, and my point, P, I'll call it P, is 3, -2, 8. Okay? And so the equation, 1 times x minus 3 plus, then I'm going to go 1 times y plus 2. And then I'm going to go minus 1 times z minus 8. And that's equal to 0. So x minus 3 plus y plus 2, and then distributing the -1 inside, I'm going to say minus z plus 8 equals 0. So x plus y minus z, and then -3 plus 2 is -1, -1 plus 8 is 7. So x plus y minus z plus 7 equals 0. And that's how example 3 works. So let's take a look at example 4. Suppose I want the equation of a plane through the points 0, 1, 1, 1, 0, 1, and 1, 1, 0. And remember, you have a plane, okay? And you have 3 points in the plane. So let's suppose they're right here. Now, we need a vector that runs perpendicular to the plane. And so I can form, with the known points, I can form 2 vectors in the plane. And if I take their cross product, I get a vector that's perpendicular to the plane. So I'm forming the vectors and taking the cross product of the vectors that I formed, basically. And so here, I'm going to let P equal the point 0, 1, 1. Q is the point 1, 0, 1. And then R is the point 1, 1, 0. So PQ is the vector, remember, terminal minus initial, so it's 1, negative 1, 0, okay? And then PR is the vector 1, 0, negative 1. And so my normal, which is PQ cross PR. It's the cross product of those 2 vectors. And so I claim that's going to be the vector 1, 1, 1. Okay? So now, so we're given my normal is 1, 1, 1. And we need a point. And so I'll just use P. So you can choose any of those 3 points, and I claim that it's going to work. And so P is 0, 1, 1. So 1 times x minus 0 plus 1 times y minus 1 plus 1 times z minus 1 is equal to 0. And so x plus y plus z, and then minus 1 is minus 2, is equal to 0. Now, if you wanted to check, suppose we're given n equals the vector 1, 1, 1, and what if I chose q? And then q is 1, 0, 1. And I claim you're going to get the same thing, because if you notice, 1 times x minus 1 plus 1 times y minus 0 plus 1 times z minus 1 is 0. And so x plus y plus z minus 2 is 0. And that's how you do example 4. This one's a really, it's an excellent question, because suppose we're given a plane, okay, and it passes through the point 3, 5, negative 1. And we'll call that point P. And it has to contain the line. And this line is x equals 4 minus t, y equals 2t minus 1, and z equals negative 3t. If this plane were to contain the line, I claim it must contain 2 points on the line. And so I'll call those 2 points Q and R. It doesn't matter which points you choose. If it contains the point, it contains, if it contains the line, it contains 2 points on the line. So this is what I'm going to do. I'm going to let t equal 0. That's going to produce Q. So my Q is going to be 4, -1, 0. And I'm going to let t equal 1. And then R is going to be the point 3, 1, -3. Okay. And so what I did was I reduced this question to finding the equation of a plane through 3 points. So it started with find the equation of a plane that through a point that contains a line. And now I've made it into find the equation through 3 points, because if the equation of the plane contains the line, it contains 2 points on the line. Okay. Now, so let's write down our points. So P is the point 3, 5, -1. Q is the point 4, -1, 0. And then R is the point 3, 1, -3. And so PQ is, this vector is 1, -6, 1. And then PR is the vector 0, -4, -2. And then my normal is PQ cross PR. And somebody might ask, can you do PR cross PQ? The answer is yes. Remember, you need a vector that's normal to the plane. It doesn't matter the direction as long as the vector is normal. Number one thing. So constructing n, or finding n, we get the first component should be 12 minus a -4 is 16. The second component should be 2. And the third component should be -4. Like so. So we're given the vector n is 16, 2, -4. And I'll choose Q for my point. And that point is 4, -1, 0. And so we have 16 times x minus 4 plus 2 times y minus a -1, which is y plus 1, minus 4 times z minus 0 equals 0. And so from here we get 16x minus 64 plus 2y plus 2 minus 4z equals 0. And then we can write 16x plus 2y minus 4z minus 62 equals 0. And you're not done, because I can divide everything by 2. And when I do, I get 8x plus y minus 2z minus 31 equals 0. Getting down to this bottom line would be in the most simplified form. And you could always double check, right? So if my normal is 16 to -4, and let's say I chose, doesn't matter, I can choose R, 3, 1, -3. So we should come up with the same answer. So 16 times x minus 3 plus 2 times y minus 1 minus 4 times z plus 3 is equal to 0. It doesn't look like the same answer initially, but when we go to simplify it, you should get the same answer. And so 16x minus 48, distributing the 16, plus 2y minus 2, minus 4z minus 12 equals 0. So 16x plus 2y minus 4z, and then negative 48 minus 12 is negative 60, and then negative 60 minus 2 is negative 62, so we're subtracting 62. And then dividing by 2 on both sides, we get 8x plus y minus 2z minus 31 equals 0. You don't have to check the second point, but if you check the second, and even if you go overboard, you can check the third point. And notice how we got the same answer both times. I checked for Q and checked for R. Okay, that'll do it for this video where we found the equation of a plane and we worked on 5 examples. Thank you.